This will first I will start, which is basically our experience at the UPB in facade manufacturing. Currently, we are doing everything in 2D, mainly in AutoCAD, and as we know it, most others are also doing it either in AutoCAD or Revit. And but the modeling process from architecture, we usually get a 3D model, and then after that. We model everything is modeled in AutoCAD, facade views, plan drawings, section drawings, and the limitation of this is that it's very hard to accept any changes. If the architect changes anything, first you go and change something in your facade views, then you change it into the section, afterwards you have to change it in manufacturing drawings, and it's very hard to track these changes. And also, first you draw some part in the facade view, then you draw it again in part drawings that you do to the outer companies that might manufacture something, and all the details. You basically draw the same element several times, and if something changes, then it's a complete nightmare. And the hardest part that the specification for everything is done manually. That AutoCAD and Revit, they have some tools, but it's pretty much everything is done by hand. Taking all the little things like screws, like glass, and everything is done manually. And that's how it's currently done. So the main problems for sales modeling, it's not possible to create a fast model to calculate work amount and pricing. The sales model usually needs to be done in a few days, 2 or 3 days needs to be done. And currently, it's only the sales model can only be done. You basically take PDF or AutoCAD drawings, and you just take basically area, width, height, and that's how you get the amount. AutoCAD files also, they become very slow with large projects. Up to 40 megabytes, it becomes very hard to use. Also, well, there are some workarounds, but currently AutoCAD, you can only work one person per file. Afterwards, you have to somehow copy it together. It's hard to do a clash check. You have to do drawing in 2D. You have to keep everything in mind, especially, for example, in corners, how it comes together. And the next problem then is that 2D and 3D models are used in project. That the architect is always want to send the 3D model, while you work with 2D model. And it's sometimes in the middle of the project, it's hard to put them together, especially if architect wants to see something. He wants to have feedback, and sometimes he can't understand your 2D plans. Then next, more and more clients are requiring that you also use BIM. The clients want that they can put all the industries together. Heavy construction, blade, structure, architect model, they want to put it together in one model to check how it looks. And in working in 2D, it is essential that qualified engineers work throughout the modeling, detailing process, because it's very easy to make a mistake, and you don't see how it might interact with other things. Because you work with one facade, you think in this plan you might move something, but you don't know that something is intersecting there without experience. And of course, the hardest part is manual specifications, and there are no finite parts, details, or elements in 2D systems. Okay, I won't be able to explain this one. So these are the main problems. And the advantages of modeling in 3D that it's easier to work with client and architect, that everyone works in 3D. It's very easy to clash check. You see everything in 3D, you can rotate, you can see every corner. Also, Tekla has built-in functions for clash check. If you model something in the same space intersecting, Tekla can tell you that there's a clash. It might reduce number of required software. Currently, we are doing the same job in 3 different softwares. We are drawing in AutoCAD, we are drawing in Shukal, Victop, and we are drawing in this manufacturing plant saw machine, for example, another, again. And next is that we can, this is more UPB type, that we can model heavy and facade in one single model. There are multi-user features that's for Tekla, that many people can work in single model for different details. And also, any update, this is the main point, any update in 3D model is an update in drawings. And you don't have to follow anything, you just update your 3D model, and everything further along the line is automatically updated. And it's way easier to solve complicated connections. And this is a UPB engineer, like statistics, where we spend up to like 20% of our time doing specifications, which for me feels like Stone Age. I have worked with Tekla in heavy structures for 6 years, and I can't imagine doing any specification coding by hand. It just feels old. And also, like 60% of time is being done doing drawings. With Tekla, it will be replaced with creating the model, but it will, in the end, it still is faster than doing just drawings. Doing model and getting drawings from model is faster than doing 2D drawings. And for those who don't know what Tekla is exactly capable of, the main thing that Tekla is, when you draw something in 3D in Tekla, Tekla is able to give you, it's a building information modeling type of software. It's capable of, you can get from the model any data what you want. The amount of profiles, the sizes, the weights, anything you can get, just what you can imagine. And another thing is it can, it does automatic numbering, where it can compare size. For example, you draw 600 elements, and Tekla can tell you automatically which elements are the same ones, the same number. And if you change something afterwards in the model, Tekla will automatically recalculate and give you the changed amounts, which is the same update automatically. Drawing, revisions, nothing is done by hand. Default Tekla installation isn't supposed to be for glazed structures, and we have created tools which you can download from Tekla Warehouse for free that allow you to model in 3D.
Maybe you can take a chair or
yeah. Okay. So.
Or you can sit on the other side of the table.
Okay, if you want to see my face.
I have a question before you show something.
Okay.
So from your presentation, so you're now working with 3D or with 2D yet? So for laser structure.
We
from your presentation.
At the moment, obviously, we're into this switching time between 2D and 3D. Mm-hmm. We have, I would say, still like 50-50 split. Okay. Some of because of the projects are running for a long time, yeah. And still like there's lots of processes. The switch is not easy. It has to do some with production, with project management, with sales. It's a fundamental change, and you cannot do it like during months.
So 50-50?
Around 50-50 now. Our goal is to be like 100% in 3D by the end of the year.
Okay.
It's
so
like
I have another question. You mentioned that sales model and some quantity takeoffs and so on. Is that kind of benefits of 3D? So then just question. Why? Because there are different technologies, and you mentioned that Revit also 3D technology. What as you know, you discover Revit possibilities or not? And why? What?
Particularly me, I don't have experience with Revit.
I was there when we were choosing between the 3D software we can use, and yeah, as I mentioned, we explored SolidWorks, Tapina, Revit, Tekla. All of them have their advantages and disadvantages, particularly With Revit at that time, it was something like 3 years ago. It used to get slow with as the detailing of the model increased. By now, I don't know, maybe they have addressed the issue, maybe they have not, but we made this decision 3 years ago.
So detailing level was the...
Yeah, basically, as the shapes get more complicated, the model gets slower.
I have some colleagues that have worked in Revit with heavy constructions, precast, and they have told me that Tekla is way easier for 3D modeling, at least for heavy constructions. They can't imagine going back.
For sales model, general shape, it's probably enough also, yeah? But what is your guys' purpose? You actually would like to, which kind of detailing level you are,
the detailing,
task?
A sales model needs to be like level of detail 200.
Yeah.
Just simple geometry so that you can get amounts. And why we need a 3D model, that sales model is done in 2D, and engineers afterwards, they have a hard time comparing the sold project with the actual what they have projected. It basically only after the project is done they can compare that sold was 1,000 square meters and they have projected 1,100 square meters, and then they have to find where are those extra 100 square meters. And if you would have like Tekla, like 3D sales model, we could quickly put one on top of another and we can see the difference. And also during the designing, we immediately see the difference. We can immediately contact our sales department and tell them that they have missed something, we have to change the agreement and so on.
Okay.
I think, generally the Revit and Tekla, they're pretty much on the same level. For us, the biggest argument was that we use Tekla for heavy structures. So everything's in the same software, but I wouldn't say like that one is bad and one is much better. It's case by case, but we have reached the goals we wanted with Tekla, and Revit has also the open API capabilities and so on.
Okay.
So, are you using Shukal?
Yes.
And at least for us, when designing unitized facades, we have problems that last years we don't have a simple facade that you can get from Shukal. There's always some elements that we put on top of this, some cladding, and you can't do this in Shukal. And previously we were doing it just in AutoCAD. We get from Shukal and we put it on the top of AutoCAD and do anything manually. Our first stage when implementing Tekla was that we get this unitized facade from Shukal, and afterwards we complete it in Tekla. For example, this project, I think this is unitized facade, or maybe not. Okay, so this project. So we get from Shukal the main geometry, and we quickly, it's possible in Tekla to quickly just to draw simple beams and columns. It's very easy in Tekla, the simple geometry. And afterwards, we in Tekla modeled everything that we put on this unitized facade. And in then we get all these Tekla advantages that Tekla gives us, which are the same elements, and we quickly take out the info. And afterwards we create the drawing for these added elements for the shop. And this is like the first stage. And we have done several projects like this, and it's becoming faster and faster, way faster than doing in AutoCAD. And now, next step is that we are doing in also in Tekla now, we are doing everything without touching Shukal or Victop. That we are also doing all the small details with the screws and so on, that we get everything necessary from Tekla. And during this first stage, we developed tools. First tool that we required was that Tekla comes only with heavy profiles, columns, like IPE, HEA beams, and it doesn't have those thousands of aluminium profiles. So we have developed a tool that converts any DXF profile that you have in DXF, any shape, it converts to table profile automatically. And next step was that we want to somehow quickly create a frame, and we have developed a tool. Where can I tweak it? Click it. So this computer isn't the fastest one. So this is our in-house built tool, like first version that we are slowly improving over time, where you can import the DXF file with geometry. You can either draw in AutoCAD the frame, or you can draw in this tool with coordinates or drawing here. And it will model in Tekla this frame. And for example, for unitized facade, you create one of this, like one element, and afterwards you can copy it. If you need to change some size, you can easily, quickly do it. Next step was that we required filling glass or aluminium beds.
Do you have idea how it works, this frame? To create the frame, how it works? Do you have video?
It's in warehouse, I could quickly find it. But it's pretty self-explanatory, like you draw in DXF lines just like this. And afterwards you can open the file and it imports it. And here you can just like change the numbers, and the first ID you see changes. I can apply modify and it will change in 3D model. For filling, we created, this is a universal tool that you can choose, you have like around the glass you have a perimeter of some kind of geometry. Usually it's a rectangle, but there are some weird cases where you have like a non-regular shape. So we have created a universal tool that you can select any number of elements, and it will put a filling between them. For example, you have a hexagon shape. You select these 6 elements, and it will put a glass between them. Why is nothing happening? It doesn't like that I have VPN connection also, I think. So basically this plugin lets you create this filling, and it comes automatically. You can define like gaps, glass type, name, anything that you want to you put into the model. You define it once, and afterwards you just assign where you want this filling. Sadly, I don't know why the plugin is not opening. And
do you have?
Okay, I can.
You know that you have video.
Okay, let's check it.
In YouTube, also.
The video should be attached.
Yeah.
So it's like you select any shape, and it automatically it fills it with the previously defined filling. Like for example, 3 glasses, 2 glasses, however you have defined it, with any gaps. And hopefully the demo will open it. So it automatically changes if you change something, the dynamic.
And finally, you have glass as separate piece, yeah? A separate.
Yeah.
Okay.
Okay, there won't be any diff. So here's how the plugin looks. That you define the layers, and you have to define them once. Afterwards, Tekla remembers your last used settings. And well, this should be self-explanatory also. Like it just goes through the options, but we have like thought thoroughly so that all the necessary options for engineers are included, and they are using currently this tool without like there are no problems with it. Like there are no necessary additional options currently for them. And lastly, one of the problems was that for stick facades, you have the main bearing beams, and afterwards there are several profiles on top of this main beam. We call it profile set. And we have developed a tool that allows you to model this profile set more easily, that you don't draw each beam separately.
Hello and welcome to UBB Profile Set video tutorial.
So, but this process.
The voiceover with the woman's voice because the industry is so masculine at least.
And it's also it might seem tedious, but you only do this once per each type of this profile set that you need. You do it once, and afterwards Tekla will remember this setting. You can at any time you can load this previously assembled profile set. For example, you load. And you can see that here this profile set that's consisting of 9 different parts. And afterwards, you just click on which elements you want. You assign this profile set. And like these were the main parts that we required that were not included in Tekla default installation. And afterwards, this all the other things that you need, details, for example, some kind of
Bolts.
aluminium beds, fensters, like aluminium fensters. Everything can be done in Tekla, where in Tekla it's very easy to create dynamic components without any previous knowledge. You can easily you draw one type of element in Tekla, and you can easily just you attach it to your unitized facade, and afterwards you define to Tekla that this is attached to the unitized facade, and after that you just select all the unitized facades, and Tekla will automatically attach your new part to these other facades. Where more should I go? Well, and where was it? And as you can see, we have done successfully projects in Tekla. Our next step is that following this will be presentation for our information system, and you can we'll be linking this together with Tekla, that everything will be connected. For example, here is like one simple element. It will be connected to information system together with Tekla, that we will know that there are like in project 600 of these elements. We will know that in the first floor we will need 100 of them, and manufacturing will plan when they want to manufacture them. They know exactly what amount of type are in the first floor, how many in the second floor. They can easily plan the manufacture, or also just like the assembly on site. They will have a 3D model and also plans that they see which elements they need. They plan which elements need to be delivered to site. Afterwards, workshop sees which elements are necessary, they sign which elements they need to manufacture, and the Tekla will show what parts are necessary to make to assemble these elements in shop and afterwards deliver. So I don't know. Any questions?
Can you tell me more about the output list from what can you output
It's basically
for manufacturing, let's say?
It's basically I can output anything. It's just Tekla is very user friendly. For example, in AutoCAD to do something automatically, I have to learn Lisp scripting, which I don't know, for example. But in Tekla, with very small learning time, you are able to create any kind of automatic specifications that you want, where you basically just select elements. You filter elements in a model which you want to select. You select those elements and you can get information from those elements whichever you need. For example, when you inquire the element, you get information about this element. So here's something buggy because I have opened it as a demo model. You have like the whole 3D information is in the model. You can get sizes, weight, its position numbers, its location in plan, its location in which floor it is.
And what about a CNC machine?
It can output. This is also why we are doing this. This is our current test project where we are doing everything in Tekla. Previously we got for CNC machine in Shukal and Victor. But there was this problem for unitized facades. If you attach something else which is not in Shukal, you have to do the holes in Shukal manually, which was very tedious task. It was very hard to do. So now we try to create everything in Tekla, also including all the holes, bolts in Tekla, and Tekla can output in many different standards. We have decided that we'll use a step file format. Tekla can output this step file, and then you just need most CNC machines have converters that can convert from the usual popular standards to this CNC machine standard, and most of them should recognize step file. It's a little bit difficult with Shuko machines, since they are usually locked, and then you have to go to the Shuko program developer and ask them to create a converter for you. They will ask some money for it, but it can be done.
But what kind of machines you have? Shuko?
And at least for our Shuko software, we can't import anything in it.
We have various, the ones that have Shuko software on top, they're pretty much locked, and you have to do some hacking to get into it, otherwise it's manual work in between. But the newest equipment we have bought recently, it's pretty straightforward, and you basically are using the step file, you can make the imports, so the operator doesn't have.
And previously we had this everything was done 3 times. We drew in Shukal, afterwards we drew in AutoCAD where we attached something else, and third time CNC machine operator drew it another time where he took the Shukal file and attached the holes from AutoCAD files. And now we are drawing it only once, and we are exporting a step file where CNC operator doesn't have to do anything.
So now you are piloting this.
What?
Now you are piloting this, yeah?
Yeah.
To send it to.
We are now checking that how it is that we do all the details in Tekla.
Yes. All details, but manufacturing level details.
Yeah.
Because I think this is the key difference in practice, and you guys are quite advanced in this area, because some companies using 3D models for blade structure, but it never comes to production level. It means that finally production people creating the parts drawing in AutoCAD finally.
For example, here.
So it's like you mentioned that 3 models: sales model, maybe in 3D,
Yeah.
then rest work when it comes to manufacturing, they are going to the AutoCAD anyway.
And like one of the advantages of Tekla is that I create a detail in one place, and afterwards I define this detail, and afterwards I just define where to input this detail, and it automatically copies it, but with all the 3D information, BIM information that comes with it. Like these, all the elements are details that are modeled only once, and afterwards just assign where I need them.
So probably this is quite a big difference when we're speaking about Tekla technology. Tekla technology allows to model in such deep details, in production level details, with small balls, with everything.
And what we are currently implementing, for example, is for unitized facades. We are creating like a component where first it opens like a wizard window where first you choose what type of this unitized element you will have. For example, how it is divided. Usually, for example, divided into 4 sections different. Afterwards, you can choose what type of fillings you have. Third, you choose what kind of details you have, and it designs this unitized element with dimensions you have defined. Afterwards, you copy it, you easily change details or dimensions that you need, and the design process will be the same as currently in Shukal. It will be just that you get all the additional information, so you don't have to do anything else in other programs.
Which profiles are you using? Mainly Shukal or others?
Sure.
Maybe, yeah. Okay.
Also, problem for Shukal is, at least for us, we often use custom profiles. We call them Zonder profiles. I don't know if it's industry standard. And if you need a custom profile, Shukal will send you drawing of this profile very quickly. But in Shukal, you will get this profile only after like 2 months, when you will be able to design it in Shukal. But we get this drawing, we can start designing in Tekla the next day.
Yeah. Maybe question will be later. Maybe now. Now you create the project. Now you create a quite detailed model, and there are a lot of data. What to do with this data? This is the main question. How to use for all REST processes.
The data basically, whatever for example, the guy who is assembling, whatever he needs, I can very quickly get from Tekla. He asks me how many anchors he needs to order, for example, something like that. I can get it pretty much like if I don't have a template specification for it, it takes me maybe 10 minutes to make it, and afterwards I can use it for any project. How many anchors do I need? And previously the engineers were doing it by hand, these specifications, but now we have the next presentation will be how at the end of the day engineer will just push the button to synchronize with our information system, and all the data, whatever the material needs to be ordered and stuff like that, engineer doesn't touch it at all. Engineers just draw the model, and afterwards Edgar will show you what happens with the model.